Hi, welcome to Bits and Proofs. Once embeddings and vector databases concepts are clear, now we are ready to learn Retrieval-Augmented Generation, RAG. Let's look at the full picture. You have your data, you embed it, you store those embeddings in a vector database. And then at query time, you retrieve the right pieces and get an AI answer. That final step is RAG, and that is what we build today. In the embeddings video, we learned how to turn text into numbers that carry meaning. In the vector databases video, we learned how to search those numbers fast. Today, we put it all together and build something real. So what problem does RAG actually solve? Language models are trained on public data up to a cutoff date. They know nothing about your company documents, your internal knowledge base, or your product manuals. One naive solution without RAG is to put everything into the prompt. Just copy and paste all your documents into ChatGPT or Gemini. But the context window is too small to fit all your documents and tokens. 1 million help articles will simply not fit. Another naive solution is to fine-tune the model on your data. Bake the knowledge into the weights. But this is expensive, it takes days, and the moment a document changes, your model is already stale. RAG is the practical solution. Instead of fitting all your data in one go, you retrieve only the relevant pieces at query time and give them to the model to read. It is fast, cheap, and always up to date. RAG stands for Retrieval-Augmented Generation. R for retrieval means you find the right documents from your private data store. You don't have to feed all of your documents, but just the ones you need. The A is augmented. You add those documents to the prompt. You augment the model's input with real, current, private knowledge. The G is generation. The model reads the retrieved text and generates an accurate answer. It did not learn this during training. It just reads it now. A RAG system has two clearly separated phases. The first is indexing. Indexing runs once. You load your documents, split them into chunks, embed each chunk, and store the vectors in a vector database. This is preparation. It happens before any user asks a question. The second phase is retrieval. You embed the user's question, search the vector database, retrieve the top matching chunk, stuff them into a prompt, and send it to the model. Indexing is a one-time cost. Retrieval happens in milliseconds for every question because of vector databases. When a document changes, you only re-index that document. The rest stays as is. Let's walk through indexing in detail. Imagine you have 1 million help articles. You want a system that can answer any question about them. Step 1, split each article into paragraphs. Each paragraph is one chunk. One chunk covers one topic. This is important, and we will see why in a moment. Step 2, embed each chunk. Run it through an embedding model. You get a vector, a list of numbers that captures the meaning of that paragraph. Step 3, store the vector and the original text together in the vector database. Both go in, the number representation for searching and the raw text for reading later. This whole process runs once. If a document is updated tomorrow, you re-embed only that document. Everything else stays exactly as it was. Why do we split into chunks instead of embedding the whole document? Let me show you the difference. If you embed a full article, that article probably covers many topics. Sign in, password reset, payments, account deletion. The resulting vector is a mix of all those meanings. When a user searches for reset password, the match is weak because the vector is diluted by all the other topics. If you embed a chunk, that chunk covers one topic only. The vector points clearly at that one concept. When the user searches for reset password, the match is strong and precise. Better chunks give better retrieval. Better retrieval gives better answers. Chunking strategy is one of the most important decisions in a RAG system. Now let's walk through retrieval. The user asks, how do I reset my password? Here is exactly what happens in 5 steps. Step 1, embed the question. Run it through the same embedding model you used during indexing. You get a vector that represents the meaning of that question. Step 2. Search the vector database using that vector. You are looking for chunks whose vectors are closest to the question vector. Step 3. Retrieve the 3 closest chunks by cosine similarity. These are the paragraphs most relevant to the question. Step 4. Feed those chunks into a prompt alongside the question. Step 5. Send it to the model. The model reads the chunks and produces the answer. The core technique is called context stuffing. The retrieved chunks are placed directly into the prompt before the user's question. Let me show you what that looks like. Here is a simplified prompt template. You start with a system instruction, for example, you are a helpful assistant. Then comes a section called relevant context. This is where the retrieved chunks go. Chunk 1, chunk 2, chunk 3. These are the 3 paragraphs your vector database returned. Then the user's question. Then the model answers. The model reads those retrieved chunks as if it already knew them. It did not learn this during training. It just read it right now from the prompt. That is the entire trick. The model is not magic. It is just reading. Let's compare RAG and fine-tuning directly so you know when to use which. Fine-tuning bakes knowledge into the model weights. It costs hundreds or thousands of dollars. It takes hours or days. It goes stale the moment your documents change. To update the knowledge, you retrain from scratch. RAG keeps knowledge outside the model. It costs almost nothing to set up. It is ready in minutes. It updates instantly. Change a document, re-embed it, done. The model itself never changes. For most production use cases, RAG is the right starting point. Use fine-tuning when you need to change the model's behavior or writing style, not just its knowledge. RAG is powerful, but it has limitations. You need to know these before building. First, the context window limit. You can only stuff a limited number of chunks into the prompt, usually 3 to 10. If the answer requires more context than that, you will miss it. Second, retrieval quality. If the vector search returns the wrong chunk, the model answers from the wrong information. The model cannot tell you the chunk was irrelevant. It just uses what you give it. Third, chunking strategy. Bad chunks produce bad retrieval. If your paragraphs mix too many topics or are too short to carry meaning, the search will fail. RAG is not magic. The quality of the search determines the quality of the answer. Let's see the full pattern in minimal pseudocode. This is the shape of every RAG system, regardless of which library or model you use. The indexing loop. For each document, split it into paragraphs. For each paragraph, embed it and insert the vector and text into the database. Run this once at setup and again whenever documents change. The retrieval function. Given a question, embed it, query the database for the top 3 results, join their text into a context string, build the prompt, and call the language model. That is the entire system. We covered a lot today. Let's close with 3 things to remember. 1. RAG gives a language model access to your private data without fine-tuning. You do not change the model. You change what it reads. 2. It works in 2 phases. Index your documents once. Retrieve the right ones for each question. The cost of indexing is paid once. Retrieval is fast every time. 3. The quality of retrieval determines the quality of the answer. Build good chunks, choose the right embedding model, and test your search quality before trusting the final answers. Thanks for watching. If this helped, do subscribe. More AI engineering content is coming soon. And while you are here, check out the other AI engineering videos already on the channel. See you in the next one.